Handbook of Chemistry and Physics gives solubilities of the following compounds in grams per 100 mils of water. Because these compounds are only slightly soluble, assume that the volume does not change on dissolution and calculate the solubility product for each. And then we have our example over here. So we have NH4 2PtBr6, and the solubility that they gave us was 0.59 grams per 100 milliliters. They did give us a little hint, however. They told us that this compound contains PtBr6 2- ions. And out of all of the wording here, they're only asking for one thing. They say calculate the solubility product. And remember, a solubility product is a KSP. So we're just looking for a KSP for this compound. But remember, KSPs come from balanced equations. So the first thing I have to do is I have to write a balanced equation. And it's always going to be a dissolution equation, meaning that we're going to take this slightly soluble compound, break it down into its two ions. So let's go for it. So we have NH4, 2 PtBr6, and at equilibrium, it's slightly soluble, so there's going to be a lot of this left over if we did the ice table, which we don't have to do, by the way. Just letting you know. But now we need to know what are the two ions that this compound breaks down into. Well, that's where the hint comes in. They did tell us that one of the ions, the anion, is the PtBr6. So that means that the break has to be between the polyatomic NH4 and the PtBr6. Okay, so I have NH4 as one of them, right? That's ammonia. And then we have the PtBr6. And they told us that one was a 2- already, so I'll put that there. But now we just have to know what the charge of ammonia is. Well, there's a couple of ways that we could do this, right? The easiest way is to just know that ammonia, NH4, is always a +1 charge, right? That's why we should memorize our polyatomics, because it will always help us out. You could have always just taken the other polyatomic, the PtBr6, saw that there was only one of them, crisscrossed the subscripts back up to get the NH4 as being a +1. Either way, it's fine. Now, since I have charges on both of these two are going to be aqueous. And the compound that we started with is going to be the solid ionic compound that's going to be dissolved. Now, before we move on, I have to make sure that this equation is balanced. Keep in mind that there were two ammoniums. On this side, I only have one of them. So I'm going to have to put a 2 in front of the NH4+, but then I have one whole PtBr6, one whole PtBr6, so the rest is balanced. Okay. So now, the next part of this question is to say, okay, I have a balanced equation. Let's see, can I get a KSP? Well, what's the KSP formula? It's pretty simple. It's right here. KSP always equals the concentration of the products raised to the coefficients. Generally, it's always products over reactants, but for a KSP value, the reactant is going to be a solid. And remember, no solids or liquids are allowed in any K expression. So it kind of makes it a little easier for us. So let's see. For this one, KSP would equal the concentration of the two products. We have the NH4 plus, and it's going to be multiplied by the PtBr6, 2-. Now, keep in mind that with KSPs, just be careful. You have to raise both of them to their coefficients. So for the NH4, there was a 2 in front. So that means I have to raise the concentration of NH4 to the second power. And then, since there was only one PtBr6, I can just put a 1 here, but anything raised to the first is the same. All right, so we're getting closer. But now the question is, do I know what the concentration of NH4 is? And do I know what the concentration of PtBr6? Not at the moment, but that's what we can solve for. Remember, these brackets mean molarity. And molarity, if I just put it over here, molarity is always equal to a mole value divided by a liter. But the only number that they gave us was in grams per mils. So this is now just a conversion. I somehow have to go from grams to moles, and then from milliliters to liters, and then I have the molarity. So let's do that next. So let's see, I got 0.59, and that's grams of the starting material. So that's the full-blown NH4 2PtBr6 times by a ratio. Oh, and by the way, this is over 100 milliliters, right? That was in the number that they gave us. So only work with one unit at a time. Let's just get the grams into the moles. So the grams of the NH4 2PtBr6 goes on the bottom. Moles of the NH4 2PtBr6 goes up on the top. Moles to grams is always periodic table. 1 mole is whatever the mass on the periodic table is for this compound. So, calcul's out, periodic table's out. Let's figure it out. That rhymed. With the same word. Out and out. Anyway, 2 times 14.01 plus 8 times 1.008. Okay, I got, let's see, a PT. Where is platinum? Platinum, where'd you go? Got it. 195.1. And then 6 bromines. 79.9. Okay, so this is roughly 710.584. Okie dokie. Oop. Cool. Grams cancel out with grams. We're left with the first unit that we want, which is the moles. Now let's just convert the milliliters to the liters to get that molarity unit. So since the mils are on the bottom, I have to put them on the top to cancel out. Then liters go on the bottom. And remember, it's 1,000 mils for every 1 liter. The milliliters will cancel, and now you're left with mole divided by liter. That's a molarity. So let's see. And maybe what I'll do, I'm just going to put this a little bit down. Okay. So we got 0.59 divided by 100 divided by 710.584. 584, and then times by, whoop, oh boy, what's going on? This answer times by 1,000. Okay, I'll put this in scientific notation. Woo. 8.303, 8.303, that's good enough, times 10 to the 1, 2, 3, negative 3. And that's moles over liter, which remember is capital M. And this is the molarity that we just converted and from the original. So that's this number, 8.303 times 10 to the negative third. Molarity I'll do, capital M now. But now how do I go from this value to just the NH4 plus and the PtBr6 2 minus? Well, that comes from the mole ratios. Look at those coefficients. I had 1 of the solid, we have 2 NH4s, and we have 1 PtBr6. Well, it's a 1 to 2 reaction, or not reaction, but ratio. So whatever this number is, this has to be 2 times the amount. So you would do 2 times the 8.303 times 10 to the negative third. But then since this one is only 1 to 1, it's the same number. So this is 8.303 times 10 to the negative third molarity. But let's just find out what the other one is. So 8.303 times 10 to the negative third times 2. I get And I guess I'll put in scientific notation. 1.6606 times 10 to the 2, negative 2 molarity. And these now are your 2 molarity values that are going to be used in the KSP expression that we just figured out from earlier. So KSP equals the first one that's squared, and then the second one. The first one we found out, the NH4, was the 1.6606 times 10 to the negative second. Let's see if I could just squeeze this in. Oh boy. Negative 2. And then the second one was the 8.303 times 10 to the negative third. And now I'm just going to plug this all into the calculator, and I will get the solubility product. So let's see. This squared, and then times by 8.303 times 10 to the negative third. And 2 sig figs, so 2.3 times 10 to the negative sixth. And KSPs are unitless. They have no units, so it's just a number. And there you go. What do you think, guys? Hopefully this helps. Thank you so much for viewing the video. I really hope I'm giving you great educational content out there. Check out the channel. We also have physics and math videos as well. I hope you guys are having a great day. I will talk to you later. Okay, bye-bye.